Hello friends, welcome back to my channel. It's early morning, it's approximately 5 o'clock Central European local time, and today we will perform the flight from Bergamo to Bodrum in Turkey. And it will be a little bit, most of you don't like when it is unusual routing and unusual livery, but I will try to perform it with the Norwegian livery because I didn't flew the Norwegian livery mm, for the long time. Um, so in this case, I will use this beautiful livery with Carl Nielsen. Okay, so the airplane is now in state of preliminary procedure. That means that the cabin crew are making the safety procedure, and they are as well preparing the catering services. As you can see, the aft servicing door is open and we are getting rid of waste and putting the fresh potable water into the cockpit. Okay, we are on the stands, which are a little bit remote. As you can see, this is the main terminal and this is the runway 1028. So wind condition is basically zero and there is no traffic out here, so we will perform the flight. We'll try to somehow can get the runway 10, okay? Or let's say we'll perform from runway 10. So regarding to the briefing, if you look at the chart, our estimated weights are far away below the structural weights. According to the performance weight, we'll see later on how it looks like with low cheat, but we have high cost index of 71. Our wind is basically in cruising level westerly wind configuration. We have Athena Airport its destination alternate, which is pretty fine. Because it has two separate runways, so that's absolutely perfect. And we have 168 passengers on board and check baggage 2.2 tons. And regarding to the weather, we have in destination Bodrum, we have 300 meters of general visibility, but RVR for runway 28 it's 450, and for runway 10 it's 600, and it's downgrading, so it becomes even worse. Now it's foggy, and then will be patches of fog. Okay, so well, in this case, and regarding to the NOTAMs, in Bergamo nothing special, at Bodrum nothing special. That's perfect. So all we have to need to check if we are legal to fly, how it is with Bodrum, how it is with the Bodrum airport, if this airport contains low visibility approaches or no, because otherwise we have a little bit of the problem, and we need to call the dispatch and add additional second airport. Okay, but this is flight planning. As we are coming to the airplane, we should legally fly if it is in TAF clearly stated that in Athena airport the weather 1 hour prior and 1 hour after our arrival estimated should be above applicable minima. Okay, so Bodrum we have Limo Tango Foxtrot Echo. so we have approach, ILS, I can see category 2 approach. It's within our limitations, so that's absolutely perfect. And as well runway 28 right. Absolutely perfect. Okay, so we can choose whatever runway we like. Okay, so that's all. So let's go to cockpit and make some preparation. As usual, first of all, put the battery on position. 23 voltage is quite okay. Little bit of the discharge. Alternate switch its guarded position. Here should be the plomb. And there was the sign that wasn't manipulating. With this hydraulic panel, it's in proper configuration. The wipers are parked. Gear down. In this remote stand, I don't expect the GPU, so we will start with the APU. Okay, so first of all, the fire tests. Perfect. Already detect. Okay, so first part of fire tests are completed. We can put the APU, and APU can put it on bus as soon as possible. So if we have some wheelchair, and you know what is the wheelchair, that means that these people who are who has no availability to walk by itself, so they are loading as the first prior to the any other passenger boarding, and they are going through the forward servicing door. Okay, so I can see here, I can hear the nice APU sound. Okay, so shortly. Okay, so we have APU. Okay, check the APU good quality. Continue with the tests. In order to check the wheel well fire, it's okay, perfect. Check the cargo fire compartment, it's okay. Takeoff config warning, fine. I will put the cabin and utility switch in order to have something. Put the IRSs on. Check the alignment time, service interphone off, ECR on, no reversers, crew oxygen okay, gear down 3 green, warning system okay. Circuit breakers okay. Gear door basically okay. We have 4 gear pins, circuit breakers on this side okay. Safety equipment, assume that we have all on board, and airplane documentation is valid, so and it's all on the board. So preliminary procedure is basically completed. So for just check to the journey log, and today we have some special and some kind of tricky situation. What to do, what I prepare for you. So for Captain Volker, on the logo light on, wing lights for checking of leading edge devices, and wheel well as well. So that's it. And now today in journey log, it's clearly stated that we have automatic braking system inoperative. What does it mean? If you check the master minimum equipment list, the master minimum equipment list is something which is issued by Boeing, okay, but companies has its own minimum equipment list, and it's more restrictive, for example, okay. So in our case, we assume, because in master minimum equipment list, as you can see, there is only maintenance action that's associated. Channel must be deactivated, and autobrake must be in off position, and inop sticker sub. So this leads into two conditions. First condition is to put it when you are assuming your performance calculations, because in case of rejected takeoff, you have more time for starting the braking within accelerate stop distance available, because you don't have the automatic braking. Okay, so it's count with your error. Okay, and why is this situation tricky? Because we are flying to the airport when LVO is in force, and for example, our standard operational procedures says that must be always in low visibility approach. That means within auto land, auto brake put on 2. Okay, so in this case, with the highest probability, if it is available and on standby, the light training captain or flight operation manager should be a pilot flying in this case. Okay, so we will resolve the situation like this one. Otherwise, we are not allowed to take off, because Mel says to us that it's okay, but our standard SOPs tells us that it's a problem. Okay, so this is the quite a tricky situation which we need to deal with, and that's it. So basically that's okay, and now we can release the catering service. We can release the maintenance vents, lavatory and potable water. Okay, so automatic brake, as you can see, it should be the sticker, okay, inop, and that's it. Maybe I will find it somewhere over here. It should be within the landing gear. Wheels and brakes program, brake failure, nose, anti-skid no, we discuss anti-skid. Auto brake control system, okay. In MelCDL you can find it as a non-auto brake, you can't find it, but automatic brake system, okay. So we'll put it as active, yes, that's it. So we have the failure, okay, simulated as well here. So we will start the normal pre-flight procedure. Yaw damper on, make it like this one, EFP pass switch on, emergency exit light on, window lid on, hydraulic panel is set, fine, that's perfect. Trimmer switch to the on position, we can put the APU on bleed, that's okay. Lights, everything okay. Ignition on the right side, that's perfect. This will leave for the captain walk around, and then we can go at oxygen tested 100%. A little bit low brake pressure in accumulator, so we have to ensure that we are on chokes, okay. Reset the fuel flow, lower the use, okay. Pre-select the frequencies. So that's perfect. Set up the weather radar panel, set up the transponder, ATC panel, standby 2000. I will be pilot flying, so on captain side, that's okay. And now we can perform the refueling, okay. So we will check how much fuel we need. So always when the low visibility procedures are in force or are encountered, at least 1 ton additional, okay. So we have 10.2, so 11.2, okay. Okay, so attaching. Okay, meanwhile put it, connect with external jack, put it on speaker in order to not have it on a headset. So we may start refueling. Okay, that's perfect. So now we can continue, and I have always problem here in Bergamo because there are crazy transitions right over here. I don't know what is this, what is the stand number. 805. Okay, so that's it. 805. We'll see if we have it in FMC. Not in database. Okay, so we will do it like non-standard procedure, but we have to always check it here now. And now we have taxi, airport briefing, parking stands, air coordinates, and 805. It's right here. Okay. Maybe 804 should be available, or 806, so we'll see. 804. Yeah, it's there. Okay, so 804 is there. So this middle one is not depicted right over there, but anyway we can check the coordinates within 805. Okay, 805 stop 1, stop 2, that's valid for us. 0.8, that's quite okay. So the position is basically confirmed. Okay, and now we've got the routing, and the routing is Lima Tango Foxtrot Echo. Foxtrot Echo, activate, execute, and according to our operational flight plan, our call sign is Norlight 5 Papa Lima. Okay, that's perfect, and now we can resolve the situation with a runway, but first of all we will fill the performance unit page, so 350, flight level 350, 350. I don't know what is the Bodrum altitude, so just keep it like this one. In Ryanair flight plan format there is always landing altitude, so maybe that's better solution for you, but there are missing passenger manifest, so that means that you have only zero fuel weight estimated right over there. 23539. 3539. Transition altitude. What is the transition altitude? Transition altitude is 6,000 feet here in Bergamo. I will assume higher due to the mountains terrain, but anyway, it's okay. And we have ISO deviation of -4, that means -58. 58, cost index we have 71, as I told, it's very high, and we have FMC reserve 3.3, so Athena airport it's quite far away, okay, from our destination, so that's it. And now we have Oskur, okay. So we'll check it right now. To Oskur, okay, this will lead to Bergamo. We'll try to find the Oskur as the first one. It's a little bit less complicated when you have air traffic controller. You know exactly what is the routing. So Oscar, okay. So we have Oscar right over here, and Oscar it's going from Oreo, okay. So I assume Oreo, but I would like to perform Oreo from runway 10, but maybe there is no possibility, we have to use runway 28. Yeah, it goes. It's Oreo 7 Yankee, Oreo 7 Yankee we have, and Oskur 5 November. Now it's okay, so it's basically quite fine, and we'll leave it like this for the time being. And now the captain is out of the walk around, so you can switch off these lights, and you can perform the light tests. Okay, so everything should be okay, and we'll put the QNH set 800 feet as an acceleration altitude. That means that we have 800 feet approximately as well the airport elevation, so 1600 will be our engine out acceleration altitude, okay. So okay, that's perfect. We'll look at the chart. If we have any initial climb clearance, initial climb on 10 track when leaving 1500 feet, but not before DME2 from Bergamo. VOR turning right, intercept 203 bearing from Oreo NDB, it's this one, and at DME 7.8 intercept Bergamo radial 193 to DME 12, and then we have 6000 feet, and we are coming back to Oreo Serio. Okay, so basically there is valid for category C and no speed limitations, but we can put final cruising level, which is 350 or 360. What was it? 350. Okay, so that's quite okay. Departure heading is 102. 102, and we have the first radial of 102 as well, from VOR. So that's okay. And regarding to the approach, the best situation for zero wind condition will be runway 28. Okay, so 282, 2. Okay, check the oxygen, tested 100%. Message lights, okay. Standby instruments, fine. Speed brake stowed. Parking brake set. Star levers cut off. Flaps up. Thrust levers close. Revers are close. Stop trim switch is in normal position, that's okay. And now we put the ILS frequency 108.7. Decimal 7 as the standby, or let's say on standby we will have on pilot monitoring side we will have pre-selected the active runway in case of relanding. On my side we will have the first radial, okay, which is 102, and then we are making the turn, so the Bergamo VOR is 114.905. 114.905. 114.905. That's it, and we have 376.5. Okay, so that's quite perfect. So we can put the needle of the NDB on pilot monitoring side. On our side we put the VOR, okay, in order to measure all the situation, and that's it. So we can perform the pre-flight checklist. Once the pre-flight checklist is completed, we can check what is the engine fail procedure in our case, and engine fail procedure is, I will tell you if we have any. Okay, so basically we are proceeding straight ahead to Oreo NDB, and then we are turning right to Trezo VOR and hold. So we'll put it into the fixed page, the Trezo VOR. And that's it. So okay, regarding to the services, refueling is completed, so that's absolutely perfect. We can switch off this pump and suck it from the center tank fuel pumps, and make it refueling is completed, so we can switch off the radios and start boarding, and we'll need a passenger bus because they are coming from terminal right over there. And as I said before, we have we have 168 2.2. Okay, so approximately bus arrives. So we'll start the boarding. 2.2, so 1 ton in front, and 1000 200 on the back. That's quite perfect. Okay. So to Oscar, it's basically nothing special within the routing. It's okay. As you can see, the trace of VOR for engine fail procedure is right over here. So we will climb to 5,000 feet. Okay. But as you can see, the here in this area from Bergamo VOR is minimum sector altitude 8,400 feet, but as you can see there is a flat country completely all around, so I assume that part of these hills are making this procedure like this one. I don't know why it is, but maybe because the constructions of the SIDs. So that's it. So coming back, we'll start loading front. I didn't detach the fuel truck. Okay, we can start the loading. Okay. So now we can see the rush over the airplane. Imagine all the stuff around, so the ground personnel, the guys with the loading, okay, the handling agent, the car drivers, the bus driver, the refueling guy, the maintenance crew, okay, the cabin crew, and so on and so on. And you as a captain has a responsibility to push each other in order to catch the calculated takeoff time within -5 plus 10 minutes. Okay, so otherwise you are out of way and you've got a slot time. So we have, for example, with a malfunction, because we're a little bit talking about the malfunction, and we did some briefing in the airplane. So our calculated takeoff time, it's 0510, I guess so. Okay, so we are now delay. Okay, but anyway, we'll perform the briefing and we'll call to the tower or the ground for the clearance. And once we got the clearance, everything is okay. So we can be late. So now we have only 10 minutes to ask for the clearance, the departure clearance. Or we have 10 minutes to go, okay, so. But as I said before, sometimes it could happen. So shortly we are completed with the boarding. like now, so we can get rid of bus and stairs upstairs, and we have finished always the front cargo compartment loading. Okay, so that's perfect. Now we can go to initialization page and make some load sheet and performance calculation. So we have 70 tons, okay, and we'll make it from the full runway length. So I try to calculate it from the full length of the runway. Okay, so we have 22k engines and flaps 5 for departure. Okay, engines, flaps 5 for departure, stabilizer trim should be 6.3 units. And V speeds are 147 and 151. Comparing to the 700, the V speeds are quite higher because it's reasonably higher weight. But anyway, it's okay. So 151 like this one, and that's it. So everything is prepared. So what we can do right now, action services, we can release the stairs and we can ensure the airplane is on the front chokes. We have ground personnel, okay, so we can make before start procedure 2 line. The checklist is divided before start procedure 2 line and below the line, okay, so this one is completed. Okay, so we can put somebody on the jump seat, make transponder to squawk mode Charlie, then we can ask for the clearance. Once we got the clearance, we put anti-collision lights to on position and engine start procedure. And now we are ready with the hand signal or with the headset to start the engines, but I will ensure that the ground power, this is the pushback car default, so okay. On the ground equipment is part of the before takeoff checklist, so it should be clear on the left side and clear on the right side. Anyway, so we can start the engine number 2. Okay, so we have starter cut out shortly, 56% of N2, that's okay, perfect. So we can start engine number 1. So make it L now from the ground, because there was 1500 and do not before the ME2, so I would like to be precise, okay, not forget about the situation. So I'll put L now from the ground. But VNAV from the ground has no reason, okay? And I will tell you later on why. Or I will tell you right now, because if you are performing engine fail procedure and you are making memory items and checklists, and suddenly your airplane start accelerating with the VNAV because it's right of because it was pressed the VNAV before the departure, that means that you will mess up with the procedures, and it's not good. So it's not good idea. I know that some companies are making LNAVina from the ground, but most of the companies are not doing this procedure. Okay, so we'll check the hydraulic fluid. That's okay. Flaps 5. Always when putting to flaps 5 and make lower DU on hydraulic, and you will see how it is changing with moving the flaps, okay, the fluid and the pressure, for example, okay. So now it is okay, so we can perform flight control checks. So ailerons checked, elevator checked, rudder checked, okay, that's perfect. Close it, so APU switch off, blank lower display unit, recall, everything is okay, so we are ready for taxi. We can remove the chokes, put Lex page on pilot monitoring side, put on active on VAJ, disconnect the external jack, and now we are ready to taxi. Okay, so that's it. So left side clear, assume the left side is clear, okay. Right side clear, so now we are good to go. So we'll check the taxi routing. It should be via taxiway Golf. It's this one. Okay, come on, move somehow. I always forget that when I press the mouse button, I don't have the steering. It should be better solution, like in explain. Okay, anyway, taxiway Golf. It's okay, so we can continue via taxiway Golf, okay, with the display threshold. Okay, so come back. Here we leave it like this one. That's perfect. So we can put the lights, and we are waiting for cabin crew. Once cabin crew is ready, we can perform the before takeoff procedure and before takeoff checklist. So flaps 5, green light, stabilizer 6.4 units set, so we are fully ready for departure, as you can see via taxiway Golf. Okay, so we have clearance to enter the runway, so line up procedure, put the array, pull all lights on. Okay, taxi lights switch off, and strobe and steady on position. It's quite perfect. We can go from this side of the runway. However, we are allowed to make this with the display threshold. I'm not sure right now, but I think that we are allowed from this point of view, but anyway, it's okay. So start the flight time, runway heading, it's checked, so rolling takeoff. So 40% assume is stable, stabilized takeoff and 1 toga. Now we can go. So takeoff thrust is set. Okay, we have 80 knots checked. V1 rotate. I can feel the airplane is heavy, so it's perfect. Positive rate gear up. As you can see, we have L now, okay? Pre-select it, and once we have, okay, we can couple the autopilot. Always check on FMA command, MCP speed. That's perfect. We are waiting for DME2. We have FMC message. Okay, it's going out. So we have thrust reduction altitude, and now we are going to turn. Okay, that's perfect. And now bearing, we are making a bearing. As you can see, I switched the needles, okay. We should have the bearing 230 QDR from the station, okay. So 230 approximately. As we reach 3,800 feet, we may accelerate the airplane. Okay, so now we may accelerate. We are V2 plus 15, so we can go to flaps 1. It's a little bit tricky situation because as you can see, we are a little bit out of the way with this bearing, and as I can see right now, yeah, it's quite a little bit strange situation because it's really close. Okay, this radio navigation aids. We are very close to cone of confusion right here. We should be established at 230 and we have 220, okay, so that's basically okay because he's directing to this waypoint, okay. And from that waypoint, so flaps up, sorry, I forget. From that waypoint, we should have 193. Put it back to VOR. As you can see, we have it. Okay, so we have VNOW speed, auto brake is off, landing gear up and off, engine start switches back to normal, and these lights, retractable lights are coming off when you have after takeoff checklist to line, and we have 6,000 feet, so it's transition altitudes at standard. Reading of the altimeters are okay, so checklist is completed. And now we are continue to DME12. Okay, so watch it over here. And if we have some troubles, we can stop climbing and go to Trezzo VOR. Okay. I don't know right now if we are in the clouds or not. Yeah, because of the engine anti-as I was thinking about it. So we have reached the Bergamo VOR almost 2000 feet above with thrust reduction, so it's perfect, and we are turning back to Orio al Serio NDB. So put back the needle to the NDB and as well do not forget to for a heading back. Okay, it's basic IFR rule. When direction you are turning, you turn the heading back knob as well. So we have reached the flight level 100, so that means that we can switch off the lights. We can switch off the logo light as well. We can adjust the temperature of the cabin, and we will wait for acceleration. And I will a little bit skip with the cabin crew releasing because there should be some turbulence from these mountains. When I was flying to Bergamo, I was flying to Bergamo from south of the Italy and as well from the north of the Europe, from Prague and Bratislava and so on. And there was always always over these mountains there was always but big mechanical turbulence, quite heavy turbulence. Okay, so maybe I will leave it like level change. I will keep it with 280. We will have better climb, rate of climb right now. So we are turning just exactly with the needle. Okay, so that's perfect. And as we are out of the clouds and as we are out of SID, so and it will not be bumpy, so we may release the cabin crew. Okay, now we have the O-score. And from O-score we have bearing QDR 085. Okay, 085 to O-score. And as you can see, if I zoom out a little bit, we are quite high above the mountains, but still, as you can see, the minimum sector altitude is 12,400 feet. Okay, and grid altitude is approximately the same. So I will skip the releasing the cabin crew for time being now, and leave it with 280 as turbulent, because in real life it's unexpected, absolutely. Okay, boom, and now you've got a severe turbulence, okay, from the mountains. So I will leave it this like it's now, up to approximately flight level 200, and then we can continue. Okay, so what we forget to reset the engine out acceleration altitude. So we have QDR 085, perfect needle, it's bearing behind us, so we are quite okay. Can adjust the lighting like this one. Okay, so we are shortly to all score. Basically there is no turbulence, we are out of the cloud, so we can revert it back to the V now to accelerate the airplane, and we may release the cabin crew once we are established on the en route climb speed. Always release the cabin crew when you are established on en route climb speed, because it's uncomfortable when you are, for example, accelerating and making the turn, so it's unpleasant situation for cabin crew members. Okay, so we are okay, so we may release the cabin crew like this one, put the switch with these lights, and now we are above flight level 100, so sterile cockpit it's behind us, so we can make a private conversation. So we have approximately fuel, as you can see. Right now we have approximately 2 tons in center tank. We can check if we are okay with cruise page. Optimum flight level is 370, we have 350, and maximum is 380. So the coffee corner should be very close, okay, because we are a little bit heavy. Okay, we have approximately 70% of booking capacity. We don't have so much checked baggage, so that's okay, but we have plenty of fuel. We have 10 tons of fuel. It's quite high, so we can check what is the wind condition overhead labbing point. Okay, and I will tell you overhead labbing point. Overhead labbing, if we climb a little bit higher, the temperature will decreasing, that's okay, it's basically no problem, but there is big difference between wind condition. Not big difference, it's approximately 13 knots, but 13 knots is quite high. Okay, but it's westerly configuration, and maybe a little bit the wind should be a little bit drifting from our right side, so that means that we should have more tail, more headwind component. Okay, so we will climb to flight level 350, and then we will resume on to the next. If you would like to know what is your static air temperature, it's right on the progress page number 2. As you can see, we have headwind of 2 knots and crosswind of 24 knots, 25 knots, but the wind direction will turn, and it should be approximately 2 to 0. Okay, so right now it's more or less crosswind. Okay, but later on the headwind will be rising according to the charts. There are patches of clouds. Okay, how it looks like in cabin. What should be better modeled within the PMDG, according to my opinion, it's wing light, because it should shine your leading edge device, because this is not for our patient, but but this is for our checking of leading edge devices if there is any contaminate. Okay, so it should reflect a little bit more far away. Okay. So I will see this will be reflected the light. Okay, so it should be quite better modeled. Now I was wrong with my explanation. I'm sorry, guys. It should be a tailwind component. So we can go to 370 if it is possible. Because the wind will be blowing. Yeah, it should be maybe better solution. We'll see if we are able to climb to 370. Okay, so 370, 370, and 370 as well here. No, I was wrong with my explanation. It should be drifting on this side, so we have more tailwind component. Yeah, I was wrong. That's why we are always two on board. So now we are checking the RVSMR space. The altimeters are exactly showing the same number on the captain and first officer side, and as well the standby. Autopilot is working, and on-board alerting system, I hope it works as well. We will see in cruising when we are reaching the cruising flight level. So we'll see how it looks with the buffet margin right over here. Okay, and in this case I will not explain what will be our fuel en route airport strategy, because I did it in many of videos. So I will put just into the fixed page. I will get rid of the Trezor VOR, and I will put there the airport and 250 nautical miles approximately. And if you would like to skip the video, I will skip the video once we are on the climb and we will perform all the actions. In this case, I will skip the video and we will see each other approximately 250 nautical miles before the airport, because this is the range of the VHF to catch the 80s frequency. Okay, it doesn't make sense to check it via ACARS sooner, because there should be slow visibility with downgraded action, so we'll see later on. So what will be our target climb speed? Mach number, Mach 0.79. Okay, 793, it's exactly, that's perfect. As you can see, our vertical rate of climb, it's approximately near to the service sailing. Okay, so yeah, it will be really close. Okay, cross fingers, we have 900 feet per minute. It's still okay. And I will also always making each 30 minutes the fuel check, okay? And if you look at the progress page, approximately, but there is no star and no approach right now loaded on FMC, but basically at 0740 UTC we should have our arrival to the airport, and according to our OFP, operational flight plan, we have 0743, okay, or 0735, okay. So we are a little bit late. Okay, so as you hear the sound, so that means that onboard alerting service within RVSM airspace is working. That's quite fine. So what we can do if we have the delays, so that means that for the time being we can make it nothing, because as you can see our buffered margin is very close, very close, so that means that we can speed up a little bit later on. Okay, we have FNC speed, wind of path, a little bit too soon for me, but it is okay. So now we are established. I will encounter that the stall speed should rise somewhere over here, but it's quite below, so that's okay. Anyway, okay, so right now we can perform the in-flight scan. So fuel temperature, okay, center tanks we have 1.5 ton, that's okay. Battery voltage, auxiliary battery transformer rectifier is working. TR3 standby power, it's okay. Generator 1, generator 2, it's okay. It's perfect. Then we can go down. Wing anti-ice and engine anti-ice are off. That's okay. Pressurization panel, okay, so duct pressure is okay. Temperature, it's quite high. I will put it a little bit lower. 28, okay. So 370 we've got. Fuel differential pressure, cabin altitude, that's okay, that's perfect. Lights are okay, we match our conditions, this is fine. We've got 3 times 370, 370, and we have 370 as well here, that's perfect. Hydraulic is okay, a little bit low the quantity of hydraulic system A. Fuel flow, it's okay. And to oil pressure, oil temperature, oil quantity, it's okay. Vibrations are quite fine. Feels like new engines. Okay, so that's it. So in-flight scan complete. Press recall just once again if you have some single channel failure from dual channel system, but no. So basically that's it. We'll see each other with a moment. So I will stop the video and we'll see prior the top of the descent, okay? Okay guys, so we are prior the top of the descent point, so I will reset MCP altitude, can press the descent now, and I will explain the situation. And now we have got into the situation which was my fault, because I as a captain has to realize that we are somehow not approved, and now this is the meteorological conditions as you can see on the picture right above. And from these meteorological conditions as you can see that we have 2 runway possibilities, okay? We have a runway 28 and a runway 10, okay? What is the current problem? The current problem now is that the meteorological conditions are exactly within the autoland. And if you look at the chart, you can see we are arriving from Okesa Point, okay, and from Okesa Point here to Roxep, and from Roxep to runway 10, and this is the preferential runway system, okay? The preferential runway system is a runway 10 left, okay? ILS runway 10 left, because the Jefferson charts there is stated that for ILS 28 right the glide slope it's 3.9 degrees. You have also availability to make a low visibility approach, but realize this number, okay? And if you look at the chart right here, look at this angle, okay? It's 3.3. And what is the limitations? The limitations, as you can see on the picture above, it's 3.25. So we are, however, uh, uh, there is availability of the autoland on this airport. We cannot perform the autoland because we are out of the autoland limitations. Okay, and you must realize, or let's say, must perform the autoland when you have category 2 or 3 approach, for example like this now. Okay, so it's cat 2 and it will perfectly fits for us because it's exactly on the minimums, but we are not allowed to do so. So in real life you cannot perform the autoland because we are out of autoland limitations. So what is the next procedure? We may continue to approach ban and hope the situation will improve, or we have a second option, hold over some waypoint and wait wait for the situation improvement. So okay, so at this time I will make it publish holding over this point, which is Foxtrot Echo 813. Foxtrot Echo 813 we have here, so we can put it onto the hold page. Next hold, Foxtrot Echo 813, like this one, and as you can see we have inbound course 193, so 193 with the right turns. Okay, that's it, and execute it. Okay, we have VNow speed, but it's basically okay. We can easily make it via a level change, make it via transition and put 290 because we have plenty of we have 1 hour time for holding available. Okay, so I will put the airplane to the holding, and then I will again split our video because it's boring to see when somebody is holding for 1 hour, but it is very close to the real life. So that's the tricky situation, and I as a piloting command should encounter with this situation, and my consideration that there is downgrading was okay, so I assumed the LVO, but I didn't check the charts and I didn't check properly on the Bodrum charts, and I didn't check that autoland is not available. However, the facilities are on the airport. Okay, I remember the situation because I was on one selection when there was a tricky question for me that if I am able to land or no, and as far as I remember the limitations, so I did the correct answer for them, so I'm not aware to perform the autoland because the glide's slope angle was beyond 3.25 degrees. Okay, so that's the situation. And now, as we are a little bit high on the profile, it doesn't really care because we are going to hold over this waypoint. So, and minimum holding altitude is 7,000 feet. Okay, so we can go to 7,000. So I'll put a chart right here. Now max to 50, and here we will decelerate somewhere between let's say close to this waypoint. Okay, so that's the procedure, and it looks that that weather is okay and everything is okay, but it's not true. We are not allowed. And what I will do, I will make, we have holding fuel available for 1 hour, and it will a little bit adjust when we are performing the holding. It will recalculate, and we have less holding fuel available. And in case we have holding available for 20 minutes, I will start the preparation to divert to Athena airport. Okay. So as you can see, the quite widespread fog is over the hills. Okay. And as the cabin crew has plenty of the time for landing, so we can put the fasten belts to on position approximately within flight level 150, not 200 as I was get used. So as you can see, in professional flying and real life operations, the things are not so easy that on VATSIM, for example. Okay, and as you can see, your pre-flight briefing within the briefing room, but as we are on flight simulator, we are performing the briefing in cockpit. Okay, but your briefing in your briefing room should be done very carefully and very deeply, okay, in order to avoid this situation, because it is better for me, for example, to delay the flight for example for 2 hours or 3 hours, wait with the passengers in the gate, send them some refreshment and so on and so on, like burning the fuel within the holding, and then diverting, and then calling dispatch that we need to ensure or let's say deboard the passengers to the terminal, and then put their bag and make an overfly from Athena back to Bodrum and so on. So that's not reasonable. So it was my fault that I didn't check it properly. Yes, we may perform the auto land, but if there is SAFA inspection on board, we will lose our licenses because we are not allowed to do so. So this waypoint, it's 250 Okesa. Okay. We have also availability to wait over Okesa waypoint. Okay, so we can make it via two-way procedure. Okay, now we can go to 7000. In case of Okesa, as you can see, minimum holding altitude is 8000 feet, so basically we have to realize what is our transition altitude when we were diverting, okay, and what is our minimum sector altitude so far. So we can go to 7000. which is minimum holding altitude, and press QNH 1022. I will check once again the med report 1023. Okay, it's new QNH. So we are far away from the holding waypoint, and remember another limitation, what is very important, to make the holding with flaps extended with icing condition is prohibited. Okay. So we are decelerating into 250 in order to meet the speed requirement. 1 nautical mile is it's 10 knots, so 5 miles. So we can easily decelerate via this waypoint. Okay. And there was stated as well that there are birds in the vicinity of the airport, so we have to put below the flight level 100 the lights as well on. Okay. And we can put the cabin crew on position, and now you can see that we have very nicely depicted the holding procedure. It's direct entry. Okay. And we can decelerate into speed, flaps up speed, let's say, or in order to have the margin flaps to 0. Okay. So right now we can make it by vertical speed 500 feet per minute, and that's basically okay. And as you enter the holding and we establish on 7,000 feet, we will see what is the holding available. As you can now you can see that Bodrum airport is exactly right over here. Okay, so it's in this fog, and it's perfectly graphically modeled in the Microsoft Flight Simulator. So we are descending, but we are not hurry. Always, what is boring to turn the heading back within your holding. In case of you, air traffic controller gives you the radar heading to leave the holding pattern. Okay, so this is annoying a little bit, but yeah, well, basically that's okay. No problems. So now we are at the holding. As you can see, we have active here, and as you can see, we are losing 4 minutes or 5 minutes, okay, approximately. So I will skip the video and I will reposition myself in order to prepare for landing or diverting, okay. How we will deal with this situation, okay. So stay tuned. Okay guys, welcome back again. So after 20 minutes of holding, we are successful and the weather was improved, and now the RVR for runway 10 left, it's 900 meters within improvement. So as you can see on the picture above, so that's pretty perfect. And now it's time not to hurry. Auto brake we have off position because, as we were talking about, it's inoperative with inop stickers, and we have as well set it in PMDG like now. And what is now crucial, okay, to announce the passengers and announce the cabin crew that we are landing, okay, that the weather improves, everything is fine, but we have to somehow still be prepared for any possibility. So as you can see, if we are not successful within the landing, so climb to 2100 feet on radial 010, turning right, climbing to 5000 feet, okay, to VOR and hold. So the 5000 feet will be our misapproach altitude, and VOR we have pre-selected right over here. So if I have the first officer, he will tune the navigates for particular approach. So now we may exit the hold, okay. And now we may start to prepare our approach. As you can see, we are going to avert point. We should have maximum 200 knots or below. Sorry, 200 knots and exactly 5000 feet of altitude. So we may pre-select it 5000 feet. To be honest, I'm very happy because I don't want to go to Athens. So yeah, but situation will be a little bit tricky because okay, the RVR is one thing, which is in real life conditions, and what will be depicted on flight simulator, yeah, we will see. Because if I can see this fog, well, okay. So we can go to 5000. We can make a level change. Because as you can see, the fog is still presented, but it shouldn't be for low visibility, but for Cat 1 approach for sure. and for cut 1 approach we should have 550, and now we have 900 meters of RVR, so we are good to go according to our last med report. Okay, patches of fogs, yes. Okay, now we are 1000 to level off. Put heading select, make it a little bit like now, and we can go to 4000. Localizer. We have localizer captured, approach mode 102. Set, that's pretty okay. And ROPEX, we have maximum 185 and 3600, okay, but first of all we need to cross this waypoint exactly at 4000 feet, okay. So we'll make it via continuous descent technique. So make it a little bit shallower, and ROPEX with 3600 as I said before. Okay, 3600, that's it, and we are going to with flaps 1. Speed should be 185, so we can go to flaps 5. And now we can prepare the ILS Zoo ROPEX 6000 feet, its final approach point, okay. Okay, we have glide slope captured, is approach altitude 5000 feet is set. It's pretty okay, we may start to decelerate. Can go with non-standard flaps 10 configuration, and remember that it should be isothermal layer, so that means that we will be very carefully with the engine anti-ice, okay. On decelerate, gear down, flaps 15, cabin crew landing position via PA, that's okay. Arm the speed brakes. You can adjust the flap settings for current position 139ers, so 144, flaps 25, we have approach band of 1000 feet, so we should be stabilized and with the checklist ready and airplane in landing configuration. So 144, that's it. So engine start switch is continuous, speed brake R, landing gear down, flaps 30 green light, and we should have flaps 40, so flaps 40 green light now. It's okay. I will adjust a little bit the speed. And now we have to switch to the bar minimums, because we are not performing the auto land, and the bar minimums for runway 10 left was 214. And we should have as well the ISLF. Okay, so approach light systems number 2 category. You should see at least the ground, but yeah, there's some ground reflection right over there. Okay, I can see the runway without any further problems. So that's okay. Approach lights inside. So disconnect the autopilot. Disengage the auto thrust system. Get a little bit. Okay, so landing, perfect, and full reverse thrust. So, I was not braking, so closing the thrust levers within 60 knots. We'll leave the runway on the end. Okay. This select speed method doesn't work somehow in PMDG in some situations. In some situation it's working, but now I need to disconnect the auto throttle, so it will be manual go around with automatic climb. And now what we have to realize is that okay, we have runway vacated just right now, so we stop the airplane and contact the ATC and look at the charts, okay, where we are. And now you can see we can go to Bravo 1 and stand will be according to our choice. So APU on, stop the flight time, I will leave the lights on until we cross another runway. As you can see, we have exactly 10 degrees. So okay, so we are leaving the active runway. Put the lights in correct position, and now we should concentrate when we are taxiing. AP available, AP on bus. It's perfect. We start the turn. Yeah, so for example we pick up this tent, so lights off. It's quite okay. We don't have the visual locking system, so we stop the airplane, set the parking brakes. Look at here, that's okay. AP is on bus, so shutdown procedure and shutdown checklist. Okay, so that's it, and stop the block time, release the packs. Okay, we can put the anti-collision lights off, fuel pumps, hydraulic panel, air conditioning panel, IRS is off position, standby 2000, this will go off, and I really hope you like this video, and this was the situation how you can deal with real life operations. Okay, so thank you very much for watching and have a nice day, and see you next time with the next stream soon. Bye bye.